Hello everyone, welcome to the equation web. Today we will be doing a mix of geometry and trigonometry in our problem today. So let's start with the question. Today's question will focus on a theorem called Ptolemy's theorem. So today's question is, a regular pentagon ABCDE is inscribed in a circle. Let S be the side length of the pentagon and D be the length of its diagonals. If the acute angle theta between a side and a diagonal is related by the formula S over D is equal to 2 sine theta, find the exact value of theta. So I'll give you guys some time to try and solve this question by yourself. So we can imagine this question as this image right here. So we have the pentagon inscribed in a circle. And since every single point is on the circle, we can also make a quadrilateral out of the points A, B, C, D that will help us connect this to the following theorem. So Ptolemy's theorem states that the sum of the products of the opposite sides of a cyclic quadrilateral is equal to the product of the diagonals. A cyclic quadrilateral is a quadrilateral that is inscribed inside of a circle, hence why we had to make a quadrilateral out of the pentagon that we had. So we can apply this theorem to our quadrilateral ABCD, and we get that AB times CD plus BC times AD is equal to AC times BD. And in this, we know that AB, CD, and BC are all side lengths, so we can replace that with S. And AD, AC, and BD are all diagonals, so we can replace those with D. And after we simplify, we get that S squared plus SD is equal to D squared. So we know from our givens that S over D is equal to 2 sine theta. And in our equation that we just had, we know that S squared plus SD is equal to D squared. So let's subtract everything to one side and divide both sides by D squared to get that S over D squared plus S over D minus 1 equals 0. Now this makes it really easy to substitute in a value. Since we know that S over D is equal to 2 sine theta, we can substitute that in. And we get that 2 sine theta squared plus 2 sine theta minus 1 equals 0. We can simplify and get that 4 sine squared theta plus 2 sine theta minus 1 is equal to 0. Now this is a basic quadratic, so we can use the quadratic formula. And since we only want the positive root, we can take the positive root only from the quadratic formula, and we get that sine theta is equal to root 5 minus 1 over 4. So the golden ratio, or phi, is the ratio of a pentagon's diagonal to its side. And this value is also 1 plus root 5 over 2. So if we take the reciprocal of that and multiply by 1/2, and then simplify even more, we can just get root 5 minus 1 over 4. So this connects the value that we got for sine theta with the golden ratio. And we get that sine theta is equal to 1 over 2 phi. So one identity that there is states that sine of 18 degrees is also equal to 1/2 times the reciprocal of phi, or the golden ratio, which means that theta is equal to 18 degrees, and we have our answer. Since this is not a very practical way to find the solution, I will be showing a way to prove that theta is equal to 18 degrees. So let's prove that theta is equal to 18. So we know that 5 theta is going to equal 90 degrees, and that 2 theta plus 3 theta is also going to equal the same thing. So 2 theta is equal to 90 degrees minus 3 times theta. Next, we can take the sine of both sides, and we get that sine 2 theta is equal to sine of 90 degrees minus 3 times theta. And we know from the cofunctions identity that sine of 90 minus theta is equal to cosine theta. So we can say that sine 2 theta is equal to cosine of 3 theta. Next, we can expand these out using their respective identities. So 2 sine theta cosine theta is equal to 4 times cosine cubed theta minus 3 cosine theta. Then we divide both sides by cosine theta and use that cosine squared theta is equal to 1 minus sine squared theta. Now let's distribute everything and bring it to one side, and we get the same quadratic equation that we did before. And if we solve for the positive root, we get that sine theta is equal to root 5 minus 1 over 4. And we know that theta is equal to 18. So we get that sine 18 is equal to root 5 minus 1 over 4. This proves that theta is equal to 18. So our question was, a regular pentagon ABCDE is inscribed in a circle. Let S be the side length of the pentagon and D be the length of its diagonals. If the acute angle theta between a side and a diagonal is related by the formula S over D is equal to 2 sine theta, find the exact value of theta. We found that the exact value of theta is 18 degrees. Thank you for watching, and make sure to like and subscribe.